Hello, and welcome to this course on the Mathematical Foundations for Artificial Intelligence presented by Eduonics. In the rapidly growing field of artificial intelligence, machine learning algorithms such as neural networks are being used to solve or supplement a wide variety of fascinating problems and industries such as computer vision, autonomous driving, patient diagnosis in healthcare, and education in schools. Neural networks and deep learning algorithms have the potential to solve many critical problems, and more individuals are starting to use them on a daily basis. However, these algorithms are predicated on challenging mathematical topics which are essential to understand before building, deploying, or developing networks to solve new and complex tasks. This mathematical background is exactly what this course will cover. After the lectures, projects, and quizzes in this course, you will have the mathematical foundation necessary to understand and analyze deep neural networks, the most common artificial intelligence algorithm. This course will have 3 units: linear algebra, multivariate calculus, and probability theory. In the first unit, we will talk about scalars, vectors, matrices, and tensors, matrix norms, as well as special matrices and vectors, as well as eigenvalues and eigenvectors, which are essential for decomposition. Throughout the field of machine learning, linear algebra notation is used to describe the parameters and weights and structure of different machine learning algorithms. As a result, it's absolutely essential that we develop a good linear algebra foundation so that we can understand how different neural networks are put together and how they are operating. Next, we will dive into multivariate calculus, where we will have lectures on derivatives, integrals, gradients, differential operators, as well as convex optimization. Ultimately, multivariate calculus is the learning in machine learning. It's what we use to update the parameters of our different models and improve the performance. As a result, it's essential that we cover the multivariate calculus concepts that build up into optimization. Finally, we're going to dive into probability theory, where we'll study the elements of probability. We'll talk about random variables, different probability distributions, as well as variance and expectation and special random variables. Ultimately, probability theory is used to make assumptions about the underlying data when we are designing these deep learning or artificial intelligence algorithms. As a result, it's essential that we understand some of the key probability distributions. As a result, we are going to be covering probability theory in depth. This course is going to contain these 3 units. However, it's also going to include projects in Python and R that will supplement our lectures, and we'll also have quizzes where we can assess some of the knowledge that we have been attempting to learn in the lectures and projects. I'm very excited about the projects because this will actually look at how you do linear algebra or multivariate calculus in Python or R. As a result, these techniques are often used when building or deploying actual deep neural networks. As a result, they are very valuable skills to learn and cover, and I'm happy that we can include them in this course. My name is Brendan, and I will be your instructor for the duration of this course. Thanks for joining me on this educational journey. Let's go ahead and get started.